grammar, if you are given grammar, say like, let us try to have an example, right? So this is example. Okay, so this is example 1. Okay, if you are given a grammar, E implies E plus E, or E star E, or 2 or 3 or 4. Okay, 2 or 3 or 4, right? So which means if this grammar is there, so uh, this grammar is represented grammar is representing formation of string, and we know that like this string can be formed. Which string can be formed? Say 2 plus 3 star 4. So and this 2 plus 3 star 4, which gives us a solution as a parse tree, as say 2 star 3 and 4. Okay, so this is going to be a syntax tree. Okay, for our representation. Okay, but we this is with respect to the grammar and production of the string, but this has to be in case if we want this to be understood with respect to SDT scheme. What we need to understand is that we need to write a semantic rules for this. Okay, so means what we are going to do, that if grammar is here, we have a semantic rule. Okay, if grammar is here, we have a semantic rules. So instead of representing, say, uh, instead of representing 2 3 4, we can simply write this 2 3 4 as a digit, right? So we write 2 3 4 as digits. So by this my representation will be, say for example, uh, e implies E plus E. Okay, E implies E star E, and E implies digit, right? So this has to be transformed here. This has to be transformed here as in case of a semantic rule. This has to be written. Now we need to write an attribute here, right? So additional attribute, so meta information we are going to write. So it means that we need to convert this statement as E dot value is equals to E dot value plus E dot value. Okay, so value is an additional attribute. This is dot here. So now here we have to write E dot value is equals to E dot value star E dot value. Okay, then E dot value is equals to digit dot lex value. Okay, okay, now see, this is value, this is lex value. Okay, so now the case is that this is little bit confusing, right? So means like, okay, E dot value. So but it is actually E symbol, but for understanding purpose you can say, right, it is E1, this is E2, this is E3, and this is E4. Okay, but it is E value only. Okay, so this is, so here if you look at value and lex value, right, they are additional attributes. Okay, attributes in the semantic rules. Okay, so this is going to be there. Now if I want to go for it, then I need to go for like e as e as uh, e as in this way, E plus E, right? E plus E. So E is, I can, as per the grammar, I can write it E as digit. Okay, plus then this has again a representation as E star and E. Then this has digit, this has digit. Okay, then let us look at the attributed value. So what it can hold, that attributed value. So we can say that digit dot lex value, this digit dot lex value, digit dot lex value. Okay, so this is digit dot lex value. Okay, now the order of evaluation is always top down and left to right. So it means that it starts with top down. Top down means what? Start with leftmost non-terminal and go to the leaves, right? So and this is top down, and evaluation is from left direction to the right. So please try to like the order of evaluation. Order of evaluation is um, top down and left to right. Okay, this is important, top down and left to right. So now top down and left to right means that we will start with this, go with this. Now what is E? E is, look at what is E. E is a digit. So E is a digit means like, okay, here we'll go and we'll put the values. Now lex value, what is lex value for this in order of evaluation? 2 plus 3 or star 4. So in this case the lex value that we are going to have, that value is 2, right? So we'll say the lex value is 2 here. This lex value is 2. So this is lex value is 2 means that the value which is determined by the user to play with or to start with. So this is to be substituted, this is to be reduced, or this is to be produced by this. So the production dot e dot value, so here e dot value is what? E dot value means what? This value is being assigned to E, that the value becomes here, value with the E becomes, value with the E becomes 2, right? So value with the E becomes 2 and we will go for it. So this is how exactly it is. So it will go here, then there is a plus, then it will go here. So E is being again substituted with E is being substituted, reduced to E star E production. So it will go here. So again it will go on this particular digit. So this digit evaluation here, so digit is now with respect to our grammar representation. Lex value for us will be here, lex value is our here is 3. So 3 is our lex value, then it will proceed. So E dot so so E dot lex value, E dot value is here. It will go in this particular way. Let me go with this, and it is here. Okay, so when we write it here, you'll find that lex value for here it will be 3. Here lex value is going to be 4. So it is E dot value is equals to 4. So here 3 plus 2, 3 plus 3 star 4 is here. It is evaluated. Look at here. It is evaluated E star E. So it is means 3 multiplied by 4. So it is going to be 12. So means here E dot value is going to be 12. Now here, since it is E plus E, so it is substituted as E plus E here. So 12 plus 2 is 14. Okay, so it is 2 plus 12. It is answer is 14. So in this case, E dot value is going to be 14. Okay, so this is really very important. So the attributed information which you have kept it here as this. So when you go with in this way, like if you look at bottom up parsing, or in that case, right, so this is going to be uh, reduction. So this is substitution, this is going to be reduction kind of thing. Okay, so let we can have one more example here for as far as understanding is concerned. Since this is okay, so we have got one more example here which you can take up here. This is going to be an example 2. Okay, an example 2 is like you can take at you can take it as E implies E plus T, E implies T, E implies T, T implies T star F, T implies F, F implies uh, digit, right? And the same expression we can say, but it is a really modified kind of thing, right? Some more terms are added. So if this is the grammar, then we have a semantic rule something like this. So for this, semantic rules are e dot value is equals to e dot value plus t dot value. E dot value is equals to t dot value. T dot value is equals to uh, t dot value multiplied by f dot value. T dot value is equals to f dot value, and f dot value is equals to digit dot lexval. Okay, so this is how um, the semantic rules are being done. So now, if suppose order of evaluation is top down and left to right, then you have a grammar representation. Evaluation is something like this: E implies E plus T, right? E is T, T is F, F is digit. Okay, then T is T. You can go with T is T star F. T is F. F is digit, right? F is digit. Okay, so this is how exactly it is. So if you look at adding these values here, if you look at adding these values here, so you'll find it out like um, mm, rules are here. Like, okay, so you can go with say uh, digit dot lexval. I'm adding attribute here. Lex value is what? 2. So f dot value, t dot value, e dot value. Right, this is value, this is value, this is f dot value, and then this is dot lexval. Okay, digit dot lexval, f dot value, and e dot value. Okay, now how this order of evaluation is concerned, let's try to understand this also. Now, since this order of evaluation is concerned, like it is left to right, so it will start with E. What is E? E is being substituted as T. What is T? T is substituted with F. What is F? F is digit. And what is the value of this digit to be reduced to? This is going to be 2. The value of F is being assigned to 2. T is 2. T is assigned to E, and that is 2 here. Okay, then what we will have is plus, that is order of the operator to be evaluated. Then T is being substituted with the T star F. So here, so T is T is being reduced. The T is being substituted to F. F is digit, and what is the digit now here? The digit is 3, right? So here digit is 2. So 2 3. So what is the value here? 3. What is the value that is associated with T now here? 3. So gets multiplication operator, then this is digit, which is again F is being substituted as this Lex value. So it is going to be 4 now. So what is value at here is 4. So now T is being substituted with an expression or by rule number this like semantic rule 1, 2, and 3. So this is semantic rule number 1, semantic rule number 2, semantic rule number 3, semantic rule number 4, semantic rule number 5. Okay, so which means that if I need to write it here, this semantic rule in green color, it is um, T dot value is equals to T dot value multiplied by F dot value. Okay, now look at here. So already T dot value is 3 here, multiplied by F dot value is 4 here. So 3 multiplied by 4 is T dot value is 12. Okay, so at the same time, you may have you can write a semantic rule here. So E dot value is what? E is T is right, and all that. So it is like this. So here, now here, the semantic rule for E is E dot value is equals to E dot value plus T dot value. Okay, so E dot value, which is coming all the way by substitution is 2, and T dot value is by coming with the substitution is as 12. So that is 12. So the answer is going to be 14. So here T dot value is going to be 14. So like what we are doing that we are decorating this particular parse tree with the semantic rules. So means what? When this particular parse tree is being decorated, and this decoration being happened with respect to the semantic rules, then this parse tree is called as remember, this is called as annotated parse tree. This is called as annotated parse tree, right? So this is a decorated parse. Okay, this is called as decorated parse tree. Okay, so this is also this is also called as annotated parse tree. So means parts when a parse tree is showing the values of attributes. Okay, so this means what? The decorated parse tree, which is showing the value of attributes, right? So this becomes annotated parse tree. Please remember this. This becomes annotated parse tree. So this is what exactly the uh, uh, preliminary schemes are. Syntax directed translation